Hey, let's take a minute to explore what's called percent yield. And this is commonly misunderstood, but all it is, once again, is another application of stoichiometry in real life. Okay, stoichiometry we do out of a book. Okay, we do it on paper, and it represents what would happen in a perfect world. But most of the times, reactions are not perfect. Sometimes they lose energy in certain forms. Sometimes they actually go in both directions, and they don't produce what you think they should, or at least the amounts you think they should. So we're just going to look at an analysis, a way you could do this in the lab and figure out basically how efficient is my reaction. Because most reactions don't produce exactly what you would expect them to based on stoichiometry. So I want to remind you of something we did before. Okay, we've talked about this same reaction a couple of times. And if I were to say you had X grams, okay, I'm not going to make up a number for the moment because I want to do this in general so it fits any situation. So we have a certain amount of grams of sodium, and let's say we react that with excess chlorine. And what that means is we got plenty of chlorine to make this happen. It's not going to be involved in the measurement because there's going to be lots left over. But if we put X amount of sodium, X grams of sodium, with lots and lots of chlorine, what we want to know is how many grams of sodium chloride get produced. Okay, so we're going to kind of analyze what comes out of this reaction. Now, just to remind you, we could always take this and we take our X grams of sodium and we do our normal stoichiometry, where we would turn that into grams of sodium chloride. Okay. And that's something hopefully you're getting fairly accustomed to doing. A lot of stoichiometry basically seems the same every time. Now, if I were to do this on paper, and let's just make up some numbers to make this a little bit easier to work with. Let's say I figured this out, and on paper I predicted that my reaction would produce 100 grams of sodium chloride. Okay. Now, if my reaction were perfectly efficient, it didn't lose any energy, it didn't produce any other reactants, or didn't go in both directions. There's a lot of things that are fairly complicated for this level that is hard to understand and explain. But if my reaction was perfect, stoichiometry basically tells me what should happen. We call this the theoretical yield. Okay. In theory, this is what we should get, 100 grams. So stoichiometry tells you what would happen in a perfect world. Now, in a lot of problems you're going to see of this type, you're going to see something in there that says, hey, we actually did the reaction, and we measured the amount of salt that came out of it, and we started with the same amount. We were expecting 100, but we only got 72 grams of sodium chloride to come out of this. Okay, so if we're going to look at this reaction, we're going to say, hold on, we got 72 for real, but stoichiometry said we should have got 100. Well, to find the percent yield, we would basically take 72, the actual, okay, so I'll put actual over here, over the theoretical, which is 100, okay, multiply it by 100, turn it into a percent, and this says that we have a 72% yield, or basically our reaction is 72% efficient. So whatever we think it should produce, it really only produces just under 3/4 of that. Okay, now I picked easy numbers to work with, but you could apply this to any problem you get. Okay, the theoretical yield is always going to come from stoichiometry. So you do some stoichiometry, and that tells you this number right there. You look in the problem, or you do this in a lab, and that's going to tell you what really happens in real life. And then you compare those two numbers, and you figure out how efficient your reaction is. Now watch out for a couple of very common mistakes. You got to think for a second here. Is it possible to have a reaction that produces more than what stoichiometry says it should? And the answer to that is no. You're not going to have a reaction that's more than 100% efficient. That would violate the law of conservation of mass. You can't produce more than what you started with. But you can produce less, because sometimes these reactions, whether they don't have enough energy or whether they go in both directions, they just don't complete all the way like they should. So that's the basics of what we call percent yield.